Dear teachers and students, National Mathematics Day is celebrated every year on December 22nd, the birth anniversary of Indian mathematician Srinivasa Ramanujan. It was announced by our former Prime Minister Manmohan Singh on February 26, 2012 at Madras University to mark the 125th birth anniversary of S. Ramanujan. On this day, various events are held in schools and universities by the mathematics department. The purpose of the celebration is to create an awareness among public about the importance of mathematics. Mathematics is very much involved in our day-to-day life. We may find it too hard to understand, but we need to inculcate likeness and interest in mathematics for a better life. My advice to the students is to take more interest in studying mathematics. I congratulate the mathematics department teachers at Mada School for their hard work and dedication. Wish you the best. Thank you.
Reverend Fathers, teachers, and dear students. 22nd December is a special day for Mada Maths department because this day is observed as National Mathematics Day to celebrate the achievements of Srinivasa Ramanujan. The legendary mathematician was born on this day in 1887. In 2012, the former Prime Minister Manmohan Singh declared 22nd December as National Mathematics Day. Among his other achievements, Ramanujan was also among the youngest members of British Royal Society. He became the first Indian to be elected a Fellow of Trinity College. The theories of Ramanujan transformed 20th century mathematics and continue to shape the subject in the present century. Taking this opportunity to thank Head of the Department, Ms. Annie Matthew, and other mathematics teachers for arranging various programs in connection with the National Mathematics Day. Thank you.
Respected manager, principal, teachers, parents, and my dear students. From 2012 onwards, we are celebrating December 22nd as National Mathematics Day to honor the birth anniversary of great Srinivasa Ramanuja, who gave almost 3,500 maths formulas to the world that scientists have still not been able to prove completely. As we all know, the aim of celebrating this day is to raise awareness about the importance of maths amongst people for development. I wish all the blessings of this day to you all. Thank you. Thank you very much.
Respected Manager, Father Anthony Chittapura, respected Principal, Rajan Sir, respected Vice Principal, Father Joseph Neramattam, dear teachers and my dear students. Today we are celebrating National Mathematics Day. December 22nd is chosen as the Mathematics Day to commemorate the birth anniversary of Sri Ramanujan, the greatest mathematician our country has produced. Dear students, we know that maths is gaining greater and greater importance in our world. The scientific progress of the world is based on the application of mathematics. Therefore, I would like to remind you that your progress and success in life depends very much on your excellence in the study of mathematics. I wish all of you the very best in your studies. Happy Maths Day. Thank you.
I'm Hannah Joseph from 6th F. And I am Priya Mary George from 6E.
The Indian government declared 22nd December to be the National Mathematics Day. This was announced by our former Prime Minister Manmohan Singh on 26th February 2012 at Madras University to mark 125th birth anniversary of the Indian mathematician Srinivasa Ramanujan.
He died at the age of 32 because of tuberculosis. Ramanujan gave almost 3,500 math formulas to the world, which scientists have not been able to prove till now.
Now let's move on to the skit which is connected to the Mathematics Day.
If you find any mistakes or faults within it, please excuse us.
Seven to 14. Why am I not able to do this calculate quickly? Oh, what can I do?
What are you doing there? Oh, I got multiplication problems that we had learned.
Yes, but I want to do the calculations quickly. Is there any tricks to do it fastly?
Yes, in Vedic Mathematics there is an easy way to multiply both two-digit numbers. I will show you with an example. You please listen. This is the question. 57 into 62. We need to write this like this. 57 into 62. Step 1. As usual, we need to multiply the ones place first. 7 into 2, 14. So, 4 here and 1 will become a carryover. And the step 2. 57 into 62. So, the second step, we need to cross multiply these numbers. That is 6 sevens are 42 and 5 twos are 10. Then we will add these numbers together. 2 plus 0, 2 and 4 plus 1, 5. Plus we add the carry over from the first step, that is 1. Plus 1. 52 plus 1, 53. Now write 3 here and 5 will become a carryover. Now we will move on to step 3. Step 3. Step 3. 57 into 62. And finally, we need to multiply the digits in tens place. That is 5 into 6. That is 30. And we need to add 5. That is the carryover from step 2 to 30. Carryover. 30 plus 5, 35. And then write 35 here. And that is the answer of this multiplication. 3,534. You got it?
Wow, this is very easy and simple calculation. Will you please give me a question and try it myself?
Okay, I will give you a question and you have to explain it to me. 52 into 79. So this is your question.
First, write that 52 into 79. Step 1. tens place. That is 2 into 9. 9 is equal to 18. Write 8 and 1 as carryover. Then cross multiply the digits and add. Step 2. Cross multiply the digits and add. That is 5 into 9 and 7 into 2. Five nines are 45 and 7 twos are 14. And add these numbers. 5 plus 4, 9. 4 plus 1, 5. We got 59 and carry over 1 from step 1. We got answer as 16 and write 0 here and carry over as 6. Step 3. Multiply the digits in tens place. That is 5 into 7. Is equal to 35. Plus, let's carry over 6 from the step 2. 5 plus 6, 11. 3 plus 1, 4. We got the answer as 41 and write it as 41. And the answer is 4108.
Good. Now you got it right.
Thank you very much.
Dear friends, do you know Vedic Mathematics is a collection of ancient tricks and techniques to execute arithmetic operations easily and more effectively.
It comes from the Vedas, more specifically from Adharva Veda. It helps a person to solve mathematical problems many times faster. It reduces the burden of memorizing difficult concepts.
So let's concentrate more on Vedic Mathematics also. Thank you, dear friends.
Srinivasa Ramanujan was born on 22nd December 1887 in Erode, a small village in the southern part of India. Shortly after his birth, his family moved to Kumbakonam, where his father worked as a clerk in a clothes shop. Ramanujan was a child prodigy and a mathematical genius. The greatest thing about him probably is how he turned out to be this amazing mathematician despite having a little or no formal outside exposure to advanced mathematics. He was a self-taught genius from very humble origins, completely disconnected from the world of other excelling mathematicians, and largely worked out of his own in utter isolation and often in poverty. Ramanujan possessed an incredibly amazing intuition of numbers, fractions, and infinite series, possibly like no other mathematician ever did. He churned out a huge number of significant and complex results, largely based on intuition mingled with argument and induction, and some sort of innate insight that only seemed to be possessed, often without formal proofs and coherent accounts. Ramanujan attended the local grammar school and high school, and early on demonstrated an affinity for mathematics when at age 15 he obtained an out-of-date book called A Synopsis of Elementary Results in Pure and Applied Mathematics. Ramanujan set about feverishly and obsessively studying its thousands of theorems before moving on to formulate many of his own. At the end of high school, the strength of his schoolwork was such that he obtained a scholarship to the government college in Kumbakonam. But Ramanujan's greatest asset proved also to be his Achilles heel. He lost his scholarship to both the government college and later at the University of Madras because his devotion to math caused him to let his other courses fall by wayside with little in way of prospects. In 1909, he sought government unemployment benefits. Yet, despite these setbacks, Ramanujan continued to make strides in his mathematical work and in 1911 published a 17-page paper on Bernoulli numbers in the Journal of Indian Mathematical Society. Seeking the help of members of the society, in 1912, Ramanujan was able to secure a low-level post as a shipping clerk with the Madras Port Trust, where he was able to make a living while building a reputation for himself as a gifted mathematician. Around this time, Ramanujan had become aware of the work of British mathematician G.H. Hardy, who himself had been something of a young genius, with whom he began a correspondence in 1913 and shared some of his work. After initially thinking his letters a hoax, Hardy became convinced of Ramanujan's brilliance and was able to secure him both a research scholarship at University of Madras as well as a grant from Cambridge. The following year, Hardy convinced Ramanujan to come study with him at Cambridge. During their subsequent 5-year mentorship, Hardy provided the formal framework in which Ramanujan's innate grasp of numbers could thrive. With Ramanujan publishing upwards with 20 papers of his own and more in collaboration with Hardy, Ramanujan was awarded a Bachelor of Sciences for Research from Cambridge in 1916, and in 1918 became a member of the Royal Society of London. Ramanujan made many momentous contributions to mathematics, especially number theory. Much of his work was done jointly with his benefactor and mentor, G.H. Hardy. Together, they began the powerful circle method. The circle method has played a major role in subsequent developments in analytic number theory. Of Ramanujan's published papers, 37 in total, Professor Bruce C. Bent reveals that a huge portion of his work was left behind in 3 notebooks and a lost notebook. These notebooks contain approximately 4,000 claims, all without proofs. Most of these claims have now been proved and, like his published work, continue to inspire modern-day mathematics. A biography of Ramanujan titled The Man Who Knew Infinity was published in 1991, and a movie of the same name premiered in September 2015 at the Toronto Film Festival. Years of hard work, a growing sense of isolation, and exposure to the cold, wet English climate soon took their toll on Ramanujan, and in 1917 he contracted tuberculosis. After a brief period of recovery, his health worsened, and in 1919 he returned to India. Srinivasa Ramanujan died of his illness on 26 April 1920 at the age of 32. His collected papers were published by Cambridge University Press in 1972.
Madam sir, ready?
1, 2,
Any idea for you all? Okay. And Maria John. Joan. Gia. So give a clap for them. They got a point.
Good morning to all. Respected Manager, Reverend Dr. Anthony Sipura, Principal Raj Joseph Sir, Respected Vice Principal Father Joseph Ramanujan, Head of the Department of Mathematics, Mr. Annie Matthew, respected teachers, and all my dear friends. As you all know, today we are celebrating the National Mathematics Day to commemorate the birth anniversary of Srinivasa Ramanujan. As part of the celebration, the Department of Mathematics of Mala School is organizing a math quiz competition. On behalf of the Math Department, I am glad to welcome each and every one of you to this gathering. First, let's have a silent prayer. So now let's begin the quiz. So handing over the mic to the quiz master.
So let's start the quiz. First question. Find the missing term of the following series. The series is 0, 1, 1. Please raise first.
You need to say the name of the sequence also. The team. You need to give the name of the sequence. The sequence has a particular name.
Yes, it's the velocity. Follow. Please.
Your first question is, how many months make a century? Correct answer. Second question, two mathematicians created the discovery of factors. One is the name and name the other. Yes, correct. Scientific name for fear of numbers. Fear of numbers. Correct answer. What do we get when we multiply all the numbers on a telephone pad? Correct answer. Average of first 50 natural numbers. Correct answer. So the next question is teaching me. Your first question is number system without zero. Yes, correct answer. Second question is on the 125th birthday anniversary of Ramanujan, the Indian government declared 22nd December as National Mathematics Day. In which year the celebration started?
2012.
Okay. The third question is, which movie is based on the life of Srinivasa Ramanujan?
The man who knew infinity.
Okay. The fourth question, all the sports on a dice added to which number? All the sports on a dice added to which number?
21.
Okay. The sum of exterior angles of a polygon is always
3.
correct answer.
With a total of 13 points, P3 with a total of 22 points, P3 with a total of 20 21 points. C is 35 points. C is 2 points. And C with 12 points. So, C secures the first place with 35 points. D secures second position with 22 points. And C secures third position with 21 points.
The working mechanism of a magic square is that the sum of any row or any column, or even taken diagonally, will result in the number you have thought about, which is greater than or equal to 65 and a multiple of 5. A simple magic square can be created by taking a 5 by 5 side square which contains 5 rows and 5 columns. The minimum number we can obtain from a 5 by 5 square is 65, and the largest number is any number greater than 65, which should be a multiple of 5. Here is an example of a magic square. The number we have taken here is 65. As we can see, the sum of the rows, the columns, or even taken diagonally will result in the number 65. Now think about a number that is greater than or equal to 65 and a multiple of 5. Now subtract 60 from the number you have chosen and then divide the result by 8. The number you would get should be placed in the first row, third column. Now the numbers succeeding the obtained number will be filled in such a way that the sum of any row or column will result in the first number.
I want you to pick a number that ends in a 0 or 5 and is between 65 and 300. After that, I will fill each box so that every row, every column and every main diagonal will add up to the number you're going to give me. Okay. 265. Okay. 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65. Now, I would like you to calculate this in any way you want. Horizontal, vertical, or diagonal. Okay. 55, 56, 62, 43, and 49. Okay. Would you like to do it in a different way? Okay. Okay. 51, 52, 53, 54, and 55. Yeah. Okay. Okay.